I'm V. Sri Madhakrishna. I'm going to explain the fourth experiment from DAG experiment. So my data set is actually diamonds file. So the first question is we need to calculate the sample mean for price for the price column with the sample of 500. So first we are importing the pandas as PD. After that we are loading the diamond CSV that our data set into pandas. After that we are filtering the rows as where the cut down column is equals to good. After that we are randomly selecting the 500 samples from the data filtered data. After that we are calculating the mean of the price, column those for 500 things. After that after that we are printing the above result where the solution is 3967.116. So next question is we need to calculate the sample mean for price column with the sample of 1000 and we have to observe that one. So everything we have included that. So we are printing that good column and the in price we are giving the sample of 1000 members and we are calculating the population values and we are stating that 42 and we are giving the mean values here. So after that, we are getting here as 3944 is the value. And after the third question is we need to calculate the population mean for the price column. So we are using here as the cut is good where all rows where cut is good, and we are finding the mean of price column for the entire filter data to calculate the population values. This is the third question. After that, the fourth question is we need to calculate the confidence interval like CI with sample mean for price column with sample n is equals to 500 and the confidence level of 95%. And we need to observe whether the population mean lines in CI. So first we are importing everything as numpy as NNP and we are using the previous down samples for 500. And after that, we are calculating the sample mean and sample standard deviation. And after calculating, we are calculating the standard error. The standard error formula is S by root over n. And after calculating, mm, we are using the Z value for 95% of confidence. And after that, we are giving the formula that like confidence interval equals to x plus or minus z or standard equation. After that, if we are checking whether the population mean for lies in this interval, we have used the sample question of before thing, right? We are checking here whether we have using this or not. After that, we got after that the solution will become if population mean in say confidence interval is there, it will come as true. If not there means it will come as false. If the confidence level of 95 if it's above 95 percentage, it comes true or else it comes false. So we move to the next question number 5. So the question number 5 is to change the confidence level to 99 percentage. Before we have used as 95 percentage and we have to and here we are going to use 99 percentage and we are going to see the confidence interval for the same mean for the price and column of n is equals to 500, sample is equals to 500. We are using the same sample for the question 4 and just we are changing here is just that the 99 percentage for z is equals to 2.576 and then we are computing the CA for 99 that confidence interval for 99 percentage. So this is the formula, this full and full of formula, and after that we are giving the 99 percentage here. So after printing, this is the solution. Yeah, the solution will be in decimal value, so it comes in float. So after that, question number 6. Here we have to calculate and plot the confidence intervals for 25 trial where the sample we are giving is 500 and we have to check the results as are the confidence intervals 95% for the price comment and we have to observe the results. So step 1, what we are going to do is we are going to perform 25 iterations where each time here this is the thing I am explaining now. We are going to perform 25 iterations where each time we randomly sample 500 rows for the good cut diamonds. And we are going to compute the sample mean and 95% of the confidence interval. After that, we are storing the each confidence interval, and we are going to plot those intervals and mark the population mean for reference. Okay. After referencing, we are going to observe how many confidence intervals contains the true population means. Here it explains we are looping here. We are looping 25 trials with 500 samples. This is the loop we are going to do. And after that, we are going to plot it with 25 and the 25 trials with the confidence interval of 95 percentage. So after confidence intervals, the results of this is it comes in a plot diagram. And we go to next question number 7. Here we have to calculate the correlation of coefficient using Pearson for the given table. They have given a table in our question, and in Pearson we have to calculate the weight versus blood pressure. We are going to create list and array for weight and blood pressure. See, we have created these are all the list and weight of the blood pressure, and after that we are using the correlation formula. After using the formula, we are going to directly project it, and here if HO is at 1%, we have to just reject that HO at 1%. And here we got the solution for this. Actually, this is the 10th question in our experiment. I will explain again the 10th question. The 7th question is we have to calculate the correlation coefficient using Pearson. So we are importing the data from the table and given person A, B, C, D, E and their weight and blood pressure we have given here. After that, we have given the Pearson correlation formula where weight into column blood pressure method Pearson. We are going to here we have print. This is the Pearson formula, and we got the coefficient of the correlation. And after that, eighth question is to be. Eighth question, we are going to calculate the correlation coefficient for using Spearman for the same table. Same, we are imported and the table is uploaded below before question, so we don't need to again upload it. And we are using the correlation coefficient formula for the Spearman, and after that we have printing the Spearman correlation coefficient, and we got the solution. So ninth question is we are going to calculate the covariance matrix and plot the correlation seaborne heat map for the given data. So first we are importing, here we have to go into here do the heat map, so that we have imported matplot this library, and after that we are giving the data frame in which they have given in the question. After that we are going to give the heat map thing where it will be showing this from a point to point various. These are all the things I have used. df.core, it gives the different colors and different things, and cmap it gives a cool warm color, and from 1 to -1 it starts. So this shows the this table, and this is the final solution. And after that, now we come to the 10th question, where the 10th question is we have to perform a hypothesis testing with g-test, where we are going to set up the hypothesis where mu is equals to 1800 or mu is greater than 1800. After that, we are computing the standard error here. Yes, we are computing the standard error. After computing the standard error, we go for a G statistics, where it will be uh, like 1850. Here, the 1850 minus 1800 by 14.44. It comes nearly like 3.535. And we are comparing the critical value. Here, the rigid HO at 1%, it gives the critical value, so that we get the solution at correctly. So here, after the G test, we have given here what are all the values present there, and we are giving the G test formula, and we are printing it, and reject if HO at 1% is there, it will reject, and we will get the solution at 1% and true. Thank you. Thank you.